bladder. Cool.
There's no signal.
So I'm going to move around a little bit so you can see. See how it's sort of folded up on itself? All right, now the dark here, can you see my mouse? That's the inner lining. So what kind of epithelial tissue would we find? Always transition. So underneath, so this collectively, this all these layers, this epithelial covering it, is the mucosa. Because it's got mucus and mucus layer. And then underneath, this area here is all submucosa. See how it's kind of a different look? Then all this starting here, I'm going to move the slide a little bit. It's all smooth muscle. Look at this smooth muscle. Look how much we have there. And then a real thin serosa on the outside. Everybody good? Sure. Now this is with the bladder distended, not stretched. So hopefully I can go slide over here and show you what it looks like when it's stretched out. There it is stretched out. Look at the difference. That's the bladder wall stretch.
It's like a beach.
Everybody good? Look at that slide. Okay. So the other slide I want to show you is of a kidney. Now, just to get your bearings here. Can you see it okay? Each of these little, see the little, what look like spherical structures? Just trying right there, see that one? Right? Everybody good with that one? There's one, there's one. See them? Those are renal corpuscles. We're up in the cortex. So you can see that space? What is that space? That's the capsular space. What's the circle? The sphere. That's the glomerulus. And we, which we want to, switch it to a higher magnification. Bring it into focus. See a little bit better there now. If you look at this underneath the slide, like we did in lab last semester, that's a simple squamous cell right there. That's the parietal layer of the glomerular capsule. So there's the parietal layer, there's the capsule. If you can't see the visceral layer, it's really intimately covering the glomerulus. Everybody good? So we're up in the cortex. Now if we move around a little bit, you'll see tubes. See all the tubes? They're all made of simple cuboidal cells. So we can see, for example, here's a longitudinal section of a tube. Remember how tubes and glands are almost always simple cuboidal. Here you see another one. Here you see the beautiful spherical nuclei in there. That's all the tubes. Distal convoluted tube, proximal convoluted tube, collecting tube, collecting duct. There's tubes all over the nephron, right? All over the kidney. Everybody good? All right. Now,
How did they get the model from like?
Matt, you didn't take any of that, did you? Or did you?
I did.
You're so. Not me. All right. So, what was the question?
How do they get the models from? Like, what images can they use to get these models built?
What model?
Because when I look at the slides, I look at the models region like it's not even the same thing.
Yeah.
I don't wonder.
That's like they could take it and get, like if you look at it with an electron micrograph or something, you could get that level of detail.
Can we get?
We're looking at a light microscope.
Can you go into
Yeah, we do. They would take up this whole.
row?
They're huge. Got a beam of electrons down there.
Wow, that was intense.
Yeah. Now we're ready, I think, to do the flow pattern. So everybody has to check out on them. So one more up. We're going to do blood first.
Do you see that?
So it's the harder of the two. All right. So here's what you got to realize.
Nobody is in line.
Nobody's in line.
Nobody.
So far, everybody's checked out in my other two labs. But this is the macroscopic view. This is a kidney. This is the nephron, the microscopic view. So what we're going to do first is we're going to look just at how blood comes in and out of the kidney just with the macroscope. All right. So the aorta would be here. Renal artery. Segmental artery. It's starting to move into segments. Interlobar. Now remember, these are lobes. So interlobar. Arcuate, which we've already learned. Interlobular artery. So we have aorta, renal artery, segmental artery, interlobar artery, arcuate artery, interlobular artery. So, help me out here. Aorta, renal artery, segmental artery, interlobar artery, arcuate artery, interlobular artery. Now, when you come back out the same way, but by way of vein. The only difference is there's no segmental vein. So you're going to come back out the interlobular vein, arcuate vein, interlobar vein, renal vein, inferior vena cava.
So are we skipping like the efferent, atrially?
For now.
Okay.
So I just wanted you to see that the flow in and the flow out, very, very similar, right? So we go aorta, renal artery, segmental artery, interlobar, arcuate artery, interlobular artery. We do the microscopic, which we'll do in a minute. Once we go through that, come back to interlobular vein, arcuate vein, interlobar vein, renal vein, inferior vena cava. Right? Now, what we're going to do is we want to put the microscopic in, but in the microscopic, you've already learned this with the models. So, but we'll get your bearings here. Here's the interlobular artery. Afferent arterial, glomerulus, efferent arterial, either peritubular capillaries or the vasa recta, and then come back out the interlobular vein. Let's do that. Here's the interlobular artery, afferent arterial, glomerulus, efferent arterial, peritubular capillaries, vasa recta, interlobular vein, and you're going back out. Now let's put it all together. You want to do this one more time? You got it.
Yes.
Interlobular artery, afferent arterial, glomerulus, efferent arterial, peritubular capillaries, or the vasa recta, interlobular vein. Interlobular artery, afferent arterial, glomerulus, efferent arterial, peritubular capillaries, vasa recta, interlobular vein. All right, so here's where we go, put them all together. Down the aorta, renal artery, segmental artery, interlobar artery, arcuate artery, interlobular artery. So here we are in the interlobular artery. Afferent arterial, glomerulus, efferent arterial, peritubular capillaries, or the vasa recta, interlobular vein. So here's the interlobular vein, arcuate vein, interlobar vein, renal vein, inferior vena cava. So we're good right now?